Page 149, number 20. A trough is 12 feet long and 3 feet across the top. 12 feet long, 3 feet across. Its ends are isosceles triangles with an altitude of 3 feet. If water is being pumped into the trough at 2 cubic feet per minute, how fast is the water level rising when it is 1 foot deep? Alright, let's look at this phrase. Water is being pumped into the trough at 2 cubic feet per minute. That means the volume is increasing at that rate, or dV dt. That's the volume of water. dV dt is equal to 2. How fast is the water level rising? Well, let's say we call the water level H. So this isosceles triangle represents the end of the trough, and H is the water level. So we're asked, what is dH dt? That's the rate at which the height of the water is changing. What is dH dt? When it is 1 foot deep, when H is equal to 1. So we have a formula that relates V and H, a formula for the volume of water. The volume of the water is equal to the area, this little area, the area of this little triangle here, the area of the shaded triangle, multiplied by the length of the trough multiplied by 12. Alright, so the area of a triangle is 1/2 base times height, so that would be 1/2 x times h. Right here the base is, this is an inverted triangle, the base is sitting on top. 1/2 xh times the length, and the length is 12. Alright, let's eliminate x because x and h are related. If we look at this diagram, we see that we have similar triangles. The big triangle and the small triangle are similar triangles. And we have a proportion 3:3 as x is to h. Alright, and we use that to eliminate x, to eliminate our extra variable. Alright, so that is the base is to the height in the big triangle as the base is to the height in the little triangle. And just cross multiplying, and we get that x is actually equal to h. Alright, so let's substitute. For x, we're going to substitute h, because x is equal to h, and let's multiply 1/2 times 12 is 6. And here instead of x we have h times h, that's 6h squared. Alright, now in all related rate problems we have variables that are changing with time, and we differentiate our equation with respect to time. So let's do that here. So on the left we have dV dt is equal to 12h times dH dt. And dV dt, we're told, is 2, constantly 2. And we want to find dH dt when h is equal to 1. So what we have to do now is we have to substitute h equal to 1 and then solve for dH dt. So let's do that. So we have 2 is equal to 12 times 1 and then times dH dt. Alright, and now just divide both sides by 12, and we have 2 over 12, that is 1/6, is equal to dH dt when h is equal to 1. So when h is equal to 1, the height of water is increasing at the rate of 1/6, and the units are feet per minute.